Hello and welcome. I'm Bill Wake. We're here working on evolutionary design this week. We've taken a basic interpreter we wrote a couple months back and converted it from a recursive descent parser to a parser combinator approach, more of a functional language approach. We've done the conversion. There's no more recursive descent left, but there are remnants. There are remnants of the old approach. We've got some helper methods that might be used a little bit. We've got a couple different ways we handled type checking and things like that. And so we want to get rid of that duplication. And I think once we've done that, we've kind of done the core of this changeover. We do have some things around error handling, and I've got some ideas on fixing that. We'll get to that later, I guess. All right, let's see. We're mostly in here. All right. So we have functions. Let's see. We took care of require float type. It checks one number to make sure, it checks an expression to make sure it has type number. But we have other cases where we need to check the left and the right. Okay. And the old way is, the original way was to throw an error if there was a problem. Then we introduced a new check method that it's a little more compatible with the combinator parser. It's given an expression, a token, and a list of token expressions, and it produces an optional error message. All right. We can do even more with this, but this is something we can use more with our parser. We've got a combinator that knows to look for that and decide what to do. And then let's see, did we? Okay, and then along the way, we changed our error handling approach to something that's even more compatible with the parser generator or the parser combinators. And really, I'd like to move to that. But first, let's see if anybody's using the old original. Okay, if there are, we'll get rid of them. No, okay, so that's dead code. Well, let's run tests first, just to make sure. Now, unfortunately, I mean, I have to say, this one is very succinct and to the point. This one, you have to kind of, I don't know, you have to kind of work your way through it, I guess. This one's doing more. So the first one only compares a left and a right and combines them. This one has the list of tokens and expressions, and it's building the whole giant expression from them. So this one is a pair of things, and this is a number of pairs, basically. And we're using left associativity to do it. The change I want to make, well, okay, let's take care of this first. The change I want to make, we made it so that our check method could actually produce a result. And by the time you've gone through and done these calculations, you could have just built the expression. So we're going to combine those steps. Okay. Let's see who uses this. There should be, well, certainly the operators should. I don't know if they're in other places. Okay, power parser. Yeah, these are all operators. Okay, good. And then the new style, let's just go back. Whoops. Require float type. Okay. The new style is like this, where it produces a result. Okay, so let's what would we call that? I think it's like make binary expression. And we're given this, all that, and we produce a parse result over tokens yielding an expression. Okay, and so we would like this code in here and build the expression as well. So let's find that make binary expression, the other one. Well, nope. Guess I chose poorly. This one. Okay. I'm gonna move ours down, I guess. Oh, here's a make expression that didn't move down. Well, I'm getting ahead of myself here, aren't I? Oh, didn't know it would do that. Okay. I didn't check in my first one. Okay, what did I do? Oh, okay. Let's pull this down to, I don't know. Maybe we're better off with this. Let's take this out. Okay. Make sure everything's running and let's get this checked in. Okay, so we deleted unused method, require float types, original style, and moved methods around. Okay, let me try this again. I want to do require float types. Well, I'll just take this header, fix the name, float types, and that. Okay, and so I want to do the same. Well, maybe I'm back where I started. I guess what I want to do is enforce this stuff. First type and okay, so let's copy this code down for now. Require float types. I don't know. Okay. Well, I've got it to look at. I got binary expression here. It's so simple once you have everything. All right, let's do this. Oh, golly. Okay, I want more than that. I want the whole thing. Make binary expression. Okay. I'm just gonna paste this in. Okay, we're gonna say this thing is gonna enforce results. And it's a parse result token expression. Okay. So let first expression pairs equal argument. Yes, that's a good first thing. If the pair is empty, return nil. That means there's no problem. Okay. So if the pair is not empty, then we're going to do all this stuff. These returns have to go away. Now, okay. See, it's a little goofy because you have to look at the first argument. Okay, so if the pairs is not empty, then we know we have an expression. Okay, so we're going to get the token and the expression. Well, maybe I can make this better. Okay. All right. If pairs is empty, well, now we've got just the expression. So let's return success with, oh shoot. Okay. Stumbling around here. This is the original. This was producing an expression. Okay, I'm going to make a new one. Make binary expression. I'll call it 2 just to make sure I don't mess up my arguments and stuff. Expression token expression goes to parse result token expression. Okay. Whoops. This was our old code. Okay. If the pairs is empty, I'm just going to return a success. Okay. And success gets the result value, so first expression, and it gets remaining, which we haven't put in here yet. Okay, so this thing takes the list of pairs that represent the operators and the remaining input, and if it has no pairs, then it just has the first expression and we return it. Okay. Now we're going to take the first expression. Well, this is where I think I can build the thing up. Okay. So let's say let result. Let's get the expression. And let's var result equals first expression. Okay. Then this. Okay. Now we know we have pairs, and so the first one has to be numeric. Okay, the first expression, because we only our operators only work on numbers. Okay, and so if it's not number, then it's a failure, and we'll return token position. I guess that's that's why this is down here. Okay. If first expression type, return token position. Okay, let me take this. Okay. All right. If it's empty, it's success. Otherwise, we're going to pull out the first token. Okay. If it's not numeric, then it's a failure. The token position and the message. Okay, yeah, that looks good. Okay, now I've got, I'm going to run through, let's see, first index where it's not a number. Okay, so now I'm getting the first token. I'm checking all the children, all the expressions to make sure they're all numbers. And if I have one, well, if I have none, then it's okay. So this is, let's say if it's not equal nil, then I have to return another failure. Index of pairs failure index dot zero. Okay. Type mismatch. Okay, what's your issue? Can I convert? Okay, no issue. Okay. Now, at this point, everything's okay. Man, this is so complicated. All right, at this point, everything's okay. And we want to just do the stuff from here. Okay, and we have first expert pairs. And we can just do this. Well, maybe it's even okay if I call that, huh? Return make binary expression of argument. Okay, so I'm going to be a success with that and remaining. This still feels like a hard way to find out that stuff. Okay, let's make sure we build. Okay, and let's replace one of these and see if everything's good. We'll deal with the first one first. Okay, so we need a different operator. We need this backwards kind of operator for make binary expression 2, and I'll fix the name eventually. All right, test should all pass. Okay, let's go ahead and replace all these. Make binary. Oh, that one's different. Okay, these should all work. Now, I think I can rename this to make binary expression. I'm hoping I don't have a conflict because it should be able to tell. Yeah. And actually, this one, I think this is make numeric binary expression. Okay, and then let's go back up to the relational operator. Make relational expression. It's got a different argument type because it's only allowed to have one. Okay. Yeah. Okay. And it doesn't care about float types, so that's fine. Okay, but this is... Okay. That's fine. All right, now let's go back to our require. Require float types. This should be redundant now, so it shouldn't be in there anymore. Good. Okay, so let's test. Okay, and we change require float types to make binary expression, which checks types and builds the expression. Okay, now require matching types. We'll see who uses this. Nobody. Okay, and then this, it's not very common. Maybe one place. It's relational. Okay, yeah. This, let's switch it to the other form. So func require matching types. Expression token, expression optional, and remaining of array slice of token goes to parse result token. And I think I want to do the same type. What'll change is the return types. Okay, so if the token right is nil, then we're just going to return argument. And remaining, expected expression path in key. Oh. If token right is nil, then it's just an expression and the optional part's not there, so we just return success. Otherwise, we get the contents of the token on the right, the token and the right expression. If their types are equal, then we'll return success argument remaining. And otherwise, we'll return failure index of token and whatever message we had, type is match. Okay, because token exists and we can access it. I guess I'll format this a little better. Okay, so if the token on the right is nil, the token and the right is nil, then we just have a left. We'll just return what we started with. If the types match, then that's successful and we return what we started with. Otherwise, we got a failure. Okay, so now this require matching types is the other style. So it's bar and greater. Okay, and let's see if that works. Okay, and now this is not referenced. And we'll return, okay. Require matching types. Okay. That's an old style called once. All right, let's get back up here. Okay, require matching types. Check def statement. That's new style. Okay. If go to well, this is really a make. Okay, so these two belong down in the make section. Make number. Okay. rename and move methods. Okay. Back up. Require matching types. Check def statement. Require float type. Matching type. Wait a minute. Require matching types. Require matching types. Oh, expression. Who uses this one? Well, that's kind of unfortunate. Oh, it knows it has two expressions, so it doesn't have to jump through the hoops this one did. We could pass the token in, but it would still be... it wouldn't be the optional. Well, maybe that's okay. Let me try that. Whoops, this one. So if we changed the parser a little bit, and I'm gonna try this. That. So now I've got the equals is a token and the expression parser require matching types. Upper and requires bind and token to satisfy be equivalent. Array of token targets. Bind token expression. I guess that's the match. And satisfy token dot target. That's definitely not an array. I should say that. Okay, let's undo. We're back where we started. Okay. So the issue is these. I'm not sure why it complained about the parsers matching up. Variable parser. Okay, is an expression. Match is a satisfy token. An expression parser is an expression. Yeah, I don't know that message. I think there's some confusion. I think my operator, my operator definition on this stuff, I think I must have a combination that's missing, because it sometimes seems to want an unusual thing. The other thing is, I don't feel like these parentheses should be necessary. Let's make sure this works. I guess I just did. I don't think I need that, but we'll see. Yeah, because this operator only keeps the left-hand side, so the result of this should be the variable parser's type, which is expression, right? Yeah. And so expression and expression should be okay. Require matching types. Expression. Yeah. Okay. It's close. I just don't quite have it. I mean, I wonder if I can just defer to the other one. I don't know that it's better. Maybe I want to go the other way around. Expression to type. Okay. By the time I converted it, it would be worse. Okay. Okay. I'm not quite sure what our diff is here. Oh, okay. We moved the function. Okay. I don't know the best way to say that one. Okay, so type 4, what's that? That almost seems out of place. Okay. All right, so we got a check. Let's pull this up a little. And check the float type. Check matching types 2 ways. Check predefined. Type check. Now that part seems okay. This part, this sure seems like it could go on type. It's only looking at types, and okay, yeah, I think we can move this. Okay, so what I'm going to do is go to type and add this there. It is compatible. Okay. And it's not a file private. It is compatible. This type with that type. And then back here, I'm going to delegate for starters. Where'd it go? Type check is okay, because type check is all about expressions and types and tokens. It's all mixed together. But this thing, I'm just going to delegate. Whoops. And I'll just delegate parameter type dot is compatible parameter type and argument type. And we're just returning that result, so we don't need this stuff. Okay, and if it's the only expression, then it default returns it, so that should be okay. Make sure this works. Notice I have parameter type twice, but I'm just taking the small steps to move this thing over. If the tool were better, it would just do it. Okay, I don't know. That's kind of hard to read. Parameter type is compatible with I almost want to say it the other way around, don't I? Let's do that first. I want to say argument type is compatible with parameter type. Okay, so I'm going to swap the order here. Well, I'm going to swap the name. Argument type, parameter type. Okay. And then in here, I need to swap I'm going to get rid of it in a minute, so it doesn't matter. But I'm going to make this say argument type and test. Okay, and now I'm going to swap these two as well. So let's find who calls this. And pull this. Okay. And let's fix type. Whoops. Oh, I gotta swap these two. Okay, let's check in since we got an intermediate thing. Start moving is compatible to type. And that's a refactor. Okay. And type, I want to, well, instead of argument type, I'm just going to use self. Okay. And I think it'll read better if I swap it around. Oops, my caller needs to drop the first argument. Caller drops the first argument. Okay, now I can inline this argument type. And this should not be used. Okay, he's a little behind the times. That should be okay. And I don't know the type of argument expression. Okay. All right. Okay. Good. Check user defined. Okay. Now, oh boy. This file is big. I think we cut out about 100 lines maybe, but it's still pretty big. Now, I don't know if we can... I want to split it apart somehow. Okay, one way... I mean, a very natural split would be expressions versus statements. So it would be nice, and I don't know what it'll take, let's see. Do I need? It would be nice if I could just somehow expose just this, and set it up here. And then same thing for statements. And then line parser is our parser for this file. It's the top level. It calls statement parser eventually. Okay, so let's see who's using this, because I think we might be able to pull that in. Okay, variable parser, create it, bind it, reference it here, reference it here. Statement parser. And is this expression parser? Both of them need it. Okay, so that is actually needed across both. How bad is it? Match variable and optional this, make variable array. Yeah, that's something. Okay, but if I had if I could give expression parser the variable parser, var array parser, would that suffice? This is a little tricky. Okay, so I want to pull this into its own file, and that probably means I gotta watch how this binding happens. Or, I don't know, maybe the expression parser is... Okay, what do we got here? I think we will take a break first. But I'm going to try and make expression parser its own thing. And set it in the constructor, and then do the same thing with statement parser. So you'll create this parser, you'll create this parser, and then create this parser. And then we mostly use the line parser. These guys, they get used around. Because everybody's got to call match at some point. Now maybe that duplication would be okay, that expression needs one kind. Or maybe we pass in the match. It's not a parser, it's a function that returns a parser. All right, well, 3-minute break and then we'll tackle this. Hi, welcome back. All right, let's do it. Let's get this expression parser pulled out. And I think maybe the first step is we're just going to pull the function over. So let's make a new file. Plain old Swift file. Expression.swift. Okay, and I want to make expression parser. anything it needs. Okay, so let's get all this. Pull it to expression. I'm going to leave it as a top level function for a moment. Okay, and things should be complaining. Yeah. Can I find Python? Okay, we got to import pcombo. Okay. We can't find expression parser or match. Expression parser. Oh, okay. Let's put this in a class. Expression. And we'll make this, I don't know, is there a static function? Invalid redeclaration of expression. Oh, expression parser, I guess. I don't think you should be that happy at this point. Yeah. Okay. Let's make a static. And I may get rid of the static aspect of this at some point. But basically the bind, we need this. Okay. Now match. And this is just match of a token. Token names is up here somewhere. Maybe the static is a bad idea. Okay. Now, why aren't you complaining more? Check predefined function call, make predefined function call. Well, we're going to need all these expression ones. Make numeric, make unary. No, these two belong down below. Index of token. Can I find check user defined function call? Oh, have I got two of these too? I don't know if I'm make numeric binary expression. Cannot convert variable parser. Okay. Let's pass that in. Require float type. I don't know how I missed that. One of and relops. Index of. Tokens. That's a problem. We don't have access to tokens. Let's see what else we got. Index type check. Index of is definitely problematic. Now this is also the old style call. Okay, how can I get index of? The problem is tokens is definitely I don't want the parser to know about tokens. I don't want to get buried in this either. Okay, what else we got? Are these index ofs? Yep. Okay, how can I get rid of index of? Oh dear. Okay, so my failure, I have to return a point. Oh, I really want to know the position. I hate to depend both ways. Maybe I have to. Okay. Let's do that for now. Let's make this public. And we're going to pass a syntax analyzer. I don't know. I'm definitely looking for a better way on this, but I think if I can get through straightening this all out, we might be okay. Mutual dependency, though, is not a good thing. Okay, so where's make expression parser? It's variable parser. Well, let's give it the syntax analyzer. And maybe we can pull out the token thing into its own thing or something. It shouldn't care. The problem is it doesn't care until the runtime where those tokens are, and we're trying to set this up before everything else gets going. Okay, so if I pass in syntax analyzer and I hold it, I could probably make a protocol that holds the index of it, maybe. But we'll... Yeah, let's at least change the name there. Has no initializers. Doesn't need them. Yeah, probably. Let's call this Tokenizer. And you can at least get tokenizer.index of. Okay. Now init. Okay, and now we don't need it in our here. Okay, that gets us this. It returns a bind token expression. Which is this. Okay, so in the end, that. Okay, we want to do ExpressionParser.bind. All that to get this. Okay, so we created it up there. We can use it throughout. And in the end, we bind this parser into it and return that, and hopefully can use it. Whew, okay. So now my claim is I can say expression parser equals expression parser of self dot make expression parser with variable parser, and no longer do this, and no longer do this. Big step, I know. Okay. Unfortunate. It's used before. All stored properties are initialized. Well, that is clearly a problem. I'm even going to say let's pull that in here. Find bar or array. Really? Variable parser. Variable parser. Okay, let me pull that in. I think I'm only using that because both expressions and statements can use it, but I can break it apart. Okay, so I can say let variable parser, and then I no longer need it coming in, which is a good thing. Okay. And then that goes away. I think this self is the problem. Argument past call. Let's find variable parser. Okay, I'm going to pull this up there. Okay, so that's relying on that. I don't know, this may be... Okay, so I'm going to take this out. I'm going to take this out. Okay, let's see if this works. Too big of a step. Okay, who's complaining? Make numeric binary expression. Okay, theoretically, nobody's using this anymore. Self is used. Well, I'm going to throw it away. Nobody references it before this. Okay, let's see. Okay, well, that was a big step. It's a bit of a big change. Move make expression parser to expression parser class. Okay, so that worked. That's gone. The bind is no longer there. Okay. Now we got a bunch of dead code. Make statement parser, that's clearly statements. But we got a bunch of stuff that should be okay. Check def statement. Okay, require float type. Is that used in here? Yes. Right. Okay. Require matching types. Don't think so. Assignment, okay. Well, all these, that's a statement that we looked up. Type check. Okay, delete methods from syntax analyzer. Now in expression parser. I still feel like he's not being used at this point. Yeah. Require matching types. I think we saw that one. On assignment. Yes, okay, that's a statement thing. Oh, make unary expression. That might not be used. think this got used in both. Yeah. That's a statement parser. Okay. I kind of think that's gone. Get the compiler to kind of wake up a little. Okay. Run these tests. Oh, we didn't get some off the top. Okay, that's used a lot. Well, that's used here, so safe to say it's used there. Okay. Parse single line. Excuse me. Okay. Everything should run. Okay. Excuse me. Okay. There's stuff to not love here, I will grant you. This is a little weird still. And there's something else like that. Okay. That is ExpressionParser. I think the startup is still not satisfying. We can definitely rename this. ExpressionParser.make. Okay, but it gets you, it's a fairly self-contained thing. I mean, it's a biggish file, but it's certainly smaller than the file it came from. Okay. Let's do the same thing with statement parser. And then I think we'll deal with this. We can at least make a protocol that only has the index of in it and pass that. That may mean there's, I don't know. We have to use array slice of tokens, and somebody's got to hold that. So I think the main parser is the natural place. It's got to know it. And we don't know it. We don't know the list of tokens when we create this thing, so we can't just pass the tokens in. All right. Okay, let's give it a try. This was expression parser. Okay. Okay, I don't know what happened in here. Different. Oh, we changed the name. Okay. Cool. Okay, and let's make a file for statement parser. Import pcombo and make a class. Statement parser. Okay. Okay, all that. Well, check def statement, we know that's going to come. These two we know we need. And all these statement methods. I think we'll just cut and see if we can speed up this process. Statement parser. Okay. Yes, we need match. Token names. Well, this is a little silly. But, okay, let's pull it and then we can try and get it. Okay, token a simple statement. We definitely need that. Okay, we'll have to come back to that. And that bind is not really accurate. Okay. I'm pretty sure we need to pass expression parser in, but let's see what's all the complaints are. Okay, token names we just pulled. Expression parser, there it is. Okay. I think let's do an init. Oh, I got a lot of it. Okay, we need one of. Statement parser before its declaration. Okay, we kind of have to do the same thing we did up here then. Okay, so we'll make the parser and then do the bind at the end. Okay. All right, and then I guess index of. Is that another index of? Yep. And what's this one? Well, goodness, I don't know what's going on there. Oh, make if statements. Not sure what that problem is. Cannot convert type expression. Expression array of statements and a slice to the argument. Whoa, aka expression array of expression. Like expressions instead of statements? Well, if prefix basically returns the expression. I don't know why it would work here, not there. Maybe I should get these other ones. Let's fix the index of thing, and then we can deal with the rest. Okay, so we need this, and we need the tokenizer type syntax analyzer. Why that would suddenly stop working, I don't know. Maybe. Oh. Bind token expression. Make statement should be bind token statement. Did I switch names? Statement parser. Sure enough. Okay, I guess that foolishness was that. Max line number. Okay, let's do a build. Syntax analyzer. Okay, yeah, this has to change. Expression parser self. Make statement parser. Cannot find make line. Did I pull it over a little too fast? Yep. Oh, I do have to match. Syntax analyzer. Oh, max line number is here. Oh, hate this being around all over the place. Clearly that's not what we want. Okay, extract statement parser. token names. How annoying. Well, this is interesting because there really isn't an error around it. Single line, make line. Okay, that's really all this thing does. He calls statement parser to his job. Line parser. Okay, that's this. And then calls make line on it. Okay. Yeah. All right. Excuse me. All right. Let's take a look through here. Yeah, these are all, they've all been what they've been. Okay. And then the conversions. The conversions should be easier. I don't know. I think this is probably redundant at this point. Print, yeah. I don't know. I guess when I look at them, it's like the logic kind of has to be what it is. You got an array of arguments. If there is no arguments, then you just do a print new line. And if it doesn't end with space or tab, you do a new line and otherwise print the values. Yeah. That seems like the right thing. This thing you set the prompt based on whether the token is present. And then this thing, it's really just peeling it apart. Yeah, they're all pretty minimal. Yep. Again, filling in a default. I think I can read it that way. This type being determined here, I don't know, that's a little weird. Should tokens have types? I guess that's kind of the question. Let's see if they do. Oh, that's token type. That's different. Oh, result type. Yeah. Result type. That almost would make sense. This is really like function call result, but maybe we could purpose that differently. It would be nice if tokens knew their type. And I didn't have to find it with this stuff, which I feel like we did somewhere else too. Float type. Yeah, there's a type for. Let's see, name.last. Type for a string. Type for of a string. Okay. Okay. Yeah, again, I mean, it's 300 something lines. This thing's simpler. All right, so the one thing I'm not happy with is this token stuff. And it kind of comes down to, okay, the parser is defined when the syntax analyzer gets initialized. So there's no way it can have access to these tokens. I don't know. I think I'll at least do this. Is that legal to say? I think so. Okay. And then these. Let's change the type to Tokenizer. Same thing here. And we're at least restricting the stuff that we're leaning on it for. I don't know. There may be somebody could definitely see a better way than I'm doing it here, but okay. Add protocol for Tokenizer. Excuse me. All right. Well, I think that does the basics of this. I don't think I'm going to sweat this too much, although it's annoying. Hmm. I sure wish I could make these three functions be generic enough. But the thing is, we just know the input type is a slice of something. We certainly don't know it has a token type field. Or a type field. Could we put these on the match? I mean, on the tokenizer? Okay, let's go back here. And this tokens. I don't know what index is. I don't think anybody references this. They shouldn't at this point. Okay, that's progress. Then this. Index equals 0. Okay, get rid of that. And this. Okay. Okay, so move unused fields, token and index. And then we reference tokens a bunch. Well, we reference tokens. Maybe it's not a bunch. Where do they come from? Tokens. Def part is the variable. Tokens is a bad name here. You're getting two tokens. That much is true, but let's rename this. Tokens coming in. We're not referencing the global tokens though. Okay, that's good. Whoops. Okay, so that is owned by this only. And we never, all we do with it is hand the slice off of it. Okay. And then we use it in index of wherever that got off to. Here. Let's pull out the class for this thing. I think he's going to hold the tokens. Tokenizer is probably not the right name either. Okay, he doesn't know tokens. I think we're going to initialize this with tokens array of token. Okay, let tokens be an array of tokens, initialize it, and then access it. Okay, and then in the parse, let's say sorry, equals, we'll just create one to start with. Okay, now this, okay, what if we're doing this? Tokens. I think this goes away. Oh no, we still can't pass Tokenizer. It's messy. Yeah. Okay. I definitely could have done this better. Let's do this. Let's give it a, well, let's create it once. And we'll make this a var. And I almost want this to be, okay, I'm just going to get it in and then I'll worry about it. Tokenizer.tokens. Tokenizer.tokens. Okay. This goes away because it's in there. Tokens goes away because it's up there. This is no longer a tokenizer. And these get the tokenizer. Okay. That should work. Yeah, great. Build failed. Okay. Oops. Okay, introduce tokenizer type that knows the list of tokens and index of. Okay. Now I want to push some token stuff in there. Okay, I think that'll make something better. Okay, I'd like to put some match functions in there is what I'd like to do. Okay, so can I do this? I need the token names. There's token names. Okay. And then can I do this? self-used in call. That what didn't get stored. Oh, come on. Oh, I just don't quite get it. All right, I'm trying to get this function up there. Do I need that part? I don't think so. So the problem is this. It's like I have to set it. Let's try this. Maybe it'll. No. Okay, so that now, and then this is set. I think, do I do it like that? So I'm promising it'll be set. Cannot assign to value, matches a method. Maybe that's here. Okay, so I'm promising it'll not be null by the time you want it, and then I'm setting it really early. And then this token type message to string should go away. Is that going to work? Token names. Token names. Okay, let's try the same thing there. Oh, wait, what? Token names. Why are you not present? I think it's confused. Okay, yeah, just confused. Even more than me, apparently. Okay. So I think this function is now legitimately here and not here. Let's run this. I think I'm gonna have to make two names match integer is bound nil. Okay. Yeah, that's true. Can I reference Tokenizer? No, I got the same one down below. In there, yeah. Oh, that's annoying. Oh, now, okay, let's see if that works. Then I can move it back up where I want it in the first place. Yep. Okay, I want to define the function here, and then I can just reference it here. Okay, so when you say match, you're getting this one. Now, I want to make this be match 1. Is this one not referenced? Workspace. Okay, so what we've done is we've extract methods or move methods to Tokenizer, make syntax analyzers match, use the one from there. Okay. And then I think this one, sorry, Tokenizer, let's rename this to match 1. Okay. That's matching one thing, and I could use it here. Well, I don't think I need it. Okay. Yeah. All right. So I think the next this became syntax analyzer. I think the next thing is let's set up the other parsers to use match and match 1 coming from the Tokenizer. And I think that'll pull that duplication out of them. Okay, so I'm not going to do it in 2 minutes. Okay. But basically we're going to put a match and a match one, get rid of these two, and probably need to do one of as well. Let's find usages. Yeah, it's used at least once in here. Okay, so yeah, we'll just make those parsers be on Tokenizer. I'll work on a better name. And yeah, we'll change those over. I think that'll get this duplication out of here, and I think that'll be a wrap on the parser stuff. The next piece I want to do is the error handling. We've still got some to-dos left over that we ended up with some less specific error messages, and I think I know why. Basically, the operators I defined are too fancy. They do full backtracking, and we don't need that for the parser we have. So we'll find a way to make that happen and fix that and finish this thing. Finish it either tomorrow or Monday. Okay. Thanks for joining today. Next time is tomorrow, Friday at 10 a.m. Eastern to 12:30 p.m. or at 3 to 5:30 p.m. UTC. I think I'm going to be changing my hours, but this week and next week will be the same. But probably when I get, I have a few days off, and when I get back out to change it. All right. Let's see. So, again, take care and have a good evening. Bye-bye.